All right, let's do it. Try it now. You're going to pause the video, try to do this problem, and look at all the white space I've given you. Way more than the last video. So hopefully you're good to go. Again, your notes should have all the white space. My notes did not, but my notes do now. Let's look at this problem. Good luck, and then we'll go through it together. Or you can just skip to the end of the video and see if I get the same answer as you. A company estimates that at a price of $140, there will be a demand for 4,000 items. Let's make this a little bit more fun. Let's say, what could we sell for $140? How about really good cakes? Okay, we're making really good cakes. For every $5 increase in our really good cakes, the demand's going to drop by 200 items. So we can sell 4,000 really good cakes at that price. But if we make it more expensive, the demand's going to be dropping. We're going to not be able to sell as many really good cakes. So here's something called a supply curve. We haven't talked about this yet. Fun new definition. Supply curve relates. Oh wait, no, yeah, we have. This is Q sub S, right? It relates the quantity with the price, but this is going to be solved for P instead of Q sub S. For a second, I thought it was relating supply to demand. So this again is still shows the quantity. This still shows supply with relation to price. It just solved for the wrong thing and using a different variable. Find an equilibrium price and quantity. So again, equilibrium price, that's where QS equals QD. We need QS, we need QD. So let's get into it. First, let's find Q sub S. Well, we basically already have it. That's the supply. And we know the relationship between supply and price. I'm going to rewrite this. Again, there's nothing wrong with the equation that this problem gave us, but I'm going to rewrite it to try to be consistent with the variables I'm comfortable with. And that's a good problem-solving strategy because a lot of problems that you do, I try to be consistent in this class, but in general, problems that we come with might have different variables or no variables. So translating it into the variables that you like to work with is a valid choice. So if we need to get QS by itself, how are we going to do that? Well, we can multiply both sides by 20, and that'll get Q sub S by itself. That tells us that 20p equals Q sub S. Okay, great. Part 1 is done. We also need to find Q sub D. Once we find that, we'll set both Q's equal to each other and find that equilibrium price. That's a little bit more complicated. We're going to again assume that QD is linear. So it's going to be some starting value plus some slope times how much we're selling. Okay, well, we know that at some price, we know what the demand's going to be. And every $5 increase in price, demand drops by 200. That kind of sounds like a rate of change. That kind of sounds like a slope. Now, there's a couple of ways of dealing with this slope-ish thing. Okay, you could write this as a rise over run as a slope, or you could use this to come up with a second point and use that second point as a slope. What I mean is, when I say you could use this to make a second point, well, a $5 increase means that at a $145 price, demand is going to be $3,800. It will have gone down by 200. The slope is not negative 200. Why is that? It decreases by 200 for every $5. The slope is how much does it decrease for every $1. Slope is always for one input. So the slope is actually negative 40. I think the most straightforward way is coming up with another point. I need to get us exactly where I want us. Okay, so we have 1 point, right? A price of $140 is a demand of 4,000 really good cakes. Maybe they're wedding cakes. And if we increase by $5, we decrease by 200. So now the demand's only 3,800. I think this is the most straightforward way of finding that slope of negative 40, but however you can get there is fine. Just don't write negative 200 because that would be wrong. So our slope for our demand is just going to be the change in the outputs, second minus first, over the change in the inputs, second minus first. Well, that top is negative 200. The bottom is 5. And that's another way of seeing where that negative 40 comes from. Negative number. Ooh, negative numbers make me uncomfortable. Does that make sense? Demand having a negative slope means that if we, demand should be relating, this is the quantity, be relating that to price. My mistake. It says that if we increase the price, the demand should decrease by $40. Okay, that sounds about right. If we charge more for our cakes, fewer people are going to want our cakes. So that sounds good. We need B. So we know QD is B plus M. So instead of writing plus negative 40, I'm just going to write minus a positive 40 times price. We can use either one of these points to get us our B value. I'm going to use the first one because nicer numbers. So I'm going to say when price is $140, the demand is 4,000. Let's use that. And be very careful here too, because we a lot of times talk about B as our starting value, but our starting value is not really 4,000. Like it kind of sounds like 4,000 is our starting value, but that would only be our starting value if our input variable, our P, was like how many extra dollars we're charging, which would get confusing pretty fast. If you think 4,000 might be your starting value, you can try plugging it in and seeing if it makes sense with our problems, with our inputs and outputs, with our points, like we usually try to do to verify whether things make sense. So QD is 4,000. That's equal to B, which we don't know, minus 40 times P, which is $140. Now we simplify and solve. What is that? 5,600. I'm going to use a calculator. 40 times 140. Yeah, 5,600. So add that to both sides, and you're going to get B is 9,600. So our demand, QD, is 9,600, but it decreases by 40 with every price increase. Let's write our supply and demand right next to each other. Our supply is 20 for every dollar in price. Our demand starts at 9,600, but goes down by 40 with every dollar increase in price. That's how we can interpret those slopes, interpret those B values. Every time we increase the price by $1, we are willing as a business to sell 20 extra cakes. Every time we increase the price by $1, the consumers are going to buy 20 fewer cakes. And we're curious when the amount of cakes that we want to sell matches up with the amount of cakes that people want to buy. It's a very natural thing to be curious about, right? You don't want to sell things more than people want to buy them necessarily, because then you're going to be essentially like undercutting yourself or undermining yourself. So the equilibrium price is going to be when these two things are the same. The QS is the same as QD when QS, which is 20p, is the same thing as QD, which is 9,600 minus 40p. And we just solve this equation now. Add 40p to both sides, and we get 60p, 9,600. Divide both sides by 60. And you'll get that P is, I could maybe do this in my head. I'm not going to try. 160. That's the equilibrium price. So I'm going to call it P star. Technically, it would be P star here and here and here and here, but it is P star. Equilibrium price. What's the equilibrium quantity? It's just the quantity at that price, the supply at that price, which is the same as the demand at that price because it is the equilibrium price. It's when supply and demand are the same. So we can use either one. We call it Q star because it doesn't matter whether we use the S formula or the D formula. I'm going to use the S one because it's cheaper or it's simpler. 20 times P. 3,200. Okay, so the equilibrium price. Equilibrium price is $160 for our really nice cake. And we'll sell 3,200 cakes or items. All right. There you go. And there's a lot that you can say about the equilibrium price and quantity. I'm not going to go into it now, but this section's already kind of long enough. Let me know if you have questions on this. Hopefully this helped. And have a good one.